Hi, friends. I'm recording this with students in the room, so if you hear extraneous noise, that would be the class of 2017, as I said. So today, we are interpreting remainders. We're going to be doing some word problems with division that are going to have some remainders. But when you have a word problem and you have remainders, you have to interpret them and figure out what those remainders represent. And that's what we're going to talk about today. It should be lesson 4 of unit 5. And think about each of these ways to use a remainder. So there are different scenarios. So the first scenario is you ignore it because it doesn't answer your question. So a roll of ribbon is 1,780 inches long. It takes 1 yard, or 36 inches, to wrap a gift. How many gifts can be wrapped? So if we're doing the division on this, 1,780, what am I dividing that by? 36, not the yard, because 1780 is in inches. And we were told it takes 36 inches to wrap a present. So we're doing our math here, and we've found out that we have 16 inches remaining, and this number right here represents gifts wrapped. So the question is, how many gifts can be wrapped? Well, we know that, 49 gifts. Do I have to know the remainder? It's remainder 16. Do I have to know that? Can I ignore that? That is a time where it depends on the question. Do I need to know how many are left? No, I don't need to know that. Why do you ignore the remainder? Because 16 inches isn't needed information. Okay, you don't need to know that information because that's not what was asked. What was asked was how many presents can be wrapped. Now, here's our second scenario. Sometimes you round up, take that remainder, and you round up to the next whole number. So you take your remainder and you have to count it as like a whole. So you have to add 1 to your quotient. So let's talk about this problem. There are 247 people traveling to the basketball tournament by bus. Each bus holds 52 people. How many buses will be needed? So in order to solve this problem, everybody has to be on a bus. Everybody has to be on a bus. Okay? We can't have any leftover people. So if we have any leftover people, that's a whole nother bus. So we have to add that number to our quotient. So let's do the math. You've got 247 people to spread out over 52 buses. No, 52 people to how many buses? So this number right here is going to tell me how many buses. This is how many fit on each bus, right? That's what the 52 represents. So let's do this math. So we've decided that about 4 buses at 52 each, and we're going to have to do, 17, 3, we're going to have 9. We're going to have 39 people left over. So what do we need to do to this bus count up here? Add 1 more. Why? We don't want people just what? We don't want anybody left behind. Everybody's got to go to the basketball tournament. So how many buses will we need? We will need 5 buses. Yes, 5 buses, because this remainder of 39 are people. Now, why do we round up? Because we round up because we don't want to leave anybody behind. We don't want to leave anyone behind. Another bus is needed to transport everybody. So it's really important that you see how many buses will be needed. Each bus holds 52 people. So even though this 39 is less than 52 people, they have to get to the tournament too. So it's knowing what your numbers are representing that will help you determine what you need to do with your remainder. Here is the third scenario. Sometimes you use the remainder to form a fraction. Don't flip out because fractions are our friend. Fractions are our friends. So let's read this. The 28 students in Mrs. Colby's class will share 98 slices of pizza equally. So everybody's going to get the same amount. How many slices will each child get? So we're talking about pizza, right? So we take the 98 slices, we divide it between the 28 kids. We have 3 pieces, yes, with 14 left over. What do I do with those? Well, now this becomes 14 over divided by 28 kids, right? Can you reduce 14 28s? Yes. Yes, you can, Mrs. Crane. 14 divided by 14 is 1. 28 divided by 14 is 2. So each child will get 3 whole pieces, 3½ slices each. A fraction in this case makes sense. It makes sense because we're talking about something that you can divide amongst people. Okay? So look at the division shown here. Explain how to get the fraction after you find the remainder, which we kind of did this. So really, this is 98 divided by 28. You know that, right? So you get 3 with 14 left over. Isn't this an improper fraction? Improper? Are you seeing that? It's an improper fraction. So another way for this to visually be seen is like this. The smaller number on the bottom, the bigger number on top. And when we remember how we make it from improper to mixed, is you take, here's the 3, here's the leftover over our denominator. Are you seeing that? And then this can be simplified. These are skills that we have already. This is not earth-shatteringly new. It just is in a different situation. So, there's one more after this. So this scenario is sometimes you use a decimal number. Sometimes you use a decimal number instead of the remainder. Well, what does that mean? Suppose 16 friends earned $348 at a car wash. They want to divide the money equally, which is so all of the money is going to be divided out. So now we have to think of change, right? The division at the right shows that each friend gets $21 and there are $12 left over. Dividing the 12, each friend gets an additional 12/16 or 3/4 of a dollar. How many quarters are in a dollar? 4 quarters and $1. So how much is 3 quarters? 75 cents. Are you seeing that? So let's do this example here of, and that's, you have to kind of think, the decimals, this is right back to that improper fraction thing. 12/16. So leftovers or remainder over your divisor. I know you want to forget about fractions and because they were like a bad nightmare of a dream. Fractions keep coming back because fractions are more real life math than anything else we're going to do this year. Fractions are in everything we do. Division is fractions. Okay? So let's do this example here. A rectangular garden has an area of 882 square meters. The long side of the garden has a length of 35 meters. How long is the short side? So we have to do opposite, right? So 882 divided by 35. So I have 7/35 remaining. So here's my remainder. I'm going to put it over my divisor. So really, what is that? 1/5. So it's 25 and 1/5 meter is your long short side. Yeah, but how could we do a decimal? What would it be?
25 and 5/10.
And 5/10? You think? I heard 2/10, and you would be right because you want to get this to a 10th, right? So if you have 1/5 and you want to get it to a 10th, what do you have to get to? Times 2. Times 2. Hey, yeah, that's fractions. 2/5. So it's 25 and 2/10. This is equal. Are you seeing that? Did you see what I just did? 2/10. 25 and 1/5 equals 25 and 2/10. I'm going to pause this. This is the last one. Sometimes the remainder is the answer. I know this might shock you, but guys, when I say sometimes the hardest part of the battle is understanding the question. That is your first line of understanding a word problem is understanding what it is it's asking you. So a bagel shop has 138 bagels to be packed into boxes. So here's 138 bagels. We have to put them into boxes. Each box, each into boxes of 12. So each box, so this is going to be our number of boxes, right? The extra bagels are for the workers. How many bagels will the workers get? Extra bagels are for the workers. So sometimes our remainder is the answer. You just have to be aware of it. So go ahead and do this math. So I say there's going to be 11 boxes with 12 bagels in each box. Okay? Then you're going to have 6 bagels extra. So those extra bagels are what the workers will know. This is important to see because it says the extra bagels are for the workers. How many bagels will the workers get? So it's not this 11, it's the 6 left over. So what we're about to do in class for my sickies, we are going to do Think Central 5-4. And tonight's homework is 173 and 174 SAB. 173, 174 SAB, evens only. And right now in class, we're going to tackle Think Central 5-4.